Suppose that ABCD is a quadrilateral and the midpoints of the sides AC and BD are given as E and F respectively. We need to verify that the sum of these four vectors AB, AD, CB and CD equals 4 times the vector EF. Let us begin. First, we'll try to understand the problem graphically. For this, we're going to consider a quadrilateral ABCD. So here we have the quadrilateral with vertices A, B, C, D. We're going to join the diagonals AC and BD. Now it's given here that the E is going to be the midpoint of the side AC. So let's suppose this is the point E and E divides AC in the ratio 1:1. That means bisecting it. And then we have the point F. F is going to be the midpoint of the side BD. So let's say this is our point F. Now, our goal will be to show that AB vector added to AD vector plus we have CB vector added to CD vector. The sum of these four vectors equals 4 times the vector EF. This is the vector EF. Fine. So here what we'll do a construction here. We will join point A and point F and also C and F. Now, let us consider the triangle ABD. Now in this triangle, ABD, now F divides BD in the ratio 1:1 internally. Now since it is dividing BD internally, so here we can define EF vector. So EF vector is simply going to be we'll take 1 and multiply it with the vector AB. So we have 1 times AB, that's simply AB vector, added to this particular one multiplied to the vector AD. This is the section formula that we are using, divided by 1 plus 1. So that means we have AB vector plus AD vector whole divided by 2, which means cross multiplication with 2 on both sides gives us AB vector plus AD vector equals to 2 times the vector AF. We're going to label this as number 1. Next, what we'll do, we'll consider the triangle BCD. Now in this triangle BCD, so here we again have F being the midpoint of BD, or we can say F divides BD in the ratio 1:1. So this time we are going to consider the vector CF, and we're going to define the vector CF using the internal section formula as we will have to consider the vector CD added to the vector CB. So this will be divided by 1 plus 1, which is simply equals to 2, or we can say CD vector plus CB vector. This will be equals to 2 times the vector CF. Let's label this as number 2. Now what we'll do, we're going to add equation 1 with equation number 2. We're adding 1 and 2. We have 1 plus 2. We have on the left hand side AB vector plus AD vector added to CD vector plus CB vector, and on the right hand side we have 2 times AF vector plus 2 times CF vector. Now on the left hand side that's fine because that's what we have on the left hand side of the given proof. This is fine. Now we need to show that the right hand side equals 4 times EF vector. That means we need to combine 2F AF. Let's take 2 as the common factor. AF added to CF. We need to somehow show that this equals, whole thing equals on the left hand side, on the right hand side to 4 times the vector EF. Let's go to the diagram. Now here let's consider AFC. So we're going to consider the triangle. We're going to label this as number 3 for the time being. We'll come back to this in a moment. In triangle ACF. So here E divides. Here it's already given in the problem that E divides AC in the ratio 1:1. So here we can apply the internal section formula, but we'll have to be careful with the direction of the vector. So here we'll be considering the vector FE vector. So FE vector according to the internal section formula must be equals to FA vector added to FC vector whole divided by 2, which means that we have FA vector plus FC vector. That will be equals to 2 times FE vector. But the original direction of the vector is opposite to what this particular equation is giving. So FF vector can be also expressed as negative of AF vector. Then FC vector will become negative CF vector. That will be equals to negative 2 times EF vector. So what we can do, we can multiply each terms with negative 1 on both sides, and that's going to give us EF vector plus CF vector. That will be equals to 2 times EF vector. Fine. Now let this be number 4. Now what we can do, we can substitute 4 back in number 3. So substituting 4 in 3, this is going to give us, on the left hand side we have EV vector plus AD vector plus CD vector plus CB vector, and this will be equals to 2 times AF plus CF. But what is AF plus CF? That's 2EF. So that means we have 2 times 2EF vector, which is simply 4 times EF vector, and this proves our problem. That is what we were needed to show.